All right, so today's paper is A levels May June 2021, variant 1, paper 2. All right, so let's begin. The first question says ethane dioic acid OH2CCO2H has a relative molecular mass of 90. Explain what is meant by the term relative molecular mass. All right, so the definition of relative molecular mass, basically, whenever you hear the word relative, it means the ratio of 1/12 of mass of. Okay, so relative molecular mass, we are going to define that as such, and the molecular mass is always given as the average of the isotopic masses, right? So, so the definition of relative molecular mass would be relative molecular mass is the average mass of a molecule or compound to 1/12 of mass of C12 isotope. So basically, when I tell my students what this means, basically 1/12 of mass of carbon 12 means carbon 12's mass is 12. 1/12 of means 12 upon, multiplied by 1/12 is 1, right? So for example, if something has a mass of 90, right? The relative molecular mass would also be 90 upon 1, which would be still 90. So relative molecular mass and molecular mass is the same thing. The reason why we use the word relative is because we divide the molecular mass by 1/12 of mass of carbon 12. That is basically 1. So anything divided by 1 still remains the same. Okay? So that is why we call it the relative molecular mass. Why do we do it in such a way? Because back in the day, when Avogadro and the other chemists, they were trying to calculate the molecular masses, they were trying to find ways of measuring molecular masses. They used carbon 12 isotope. They knew that carbon 12, and they considered that the mass of carbon 12 is 12 grams, okay, per mole. So they were using what we say comparative measuring, meaning they were using pan balances, and they were uh, basically understanding, or they were basically saying okay, so one side is filled with carbon 12s, all right, and then we are going to measure the other side. So for example, if we wanted to measure magnesium, which has a molecular mass of 24, right, so 1 mole of magnesium on one side would be equivalent to mass of 2 moles of carbon 12 isotopes, right, 24 grams, right, because 1 mole of magnesium is 24 grams. So they would put 2 moles of carbon 12 isotopes. So this comparison is basically why we use the word relative, because we are measuring masses of compounds compared to the mass of carbon 12 isotope. All right, so next, state the empirical formula of ethane dioic acid. Okay, so for that you need to know the molecular formula of ethane dioic acid. If you see, ethane dioic acid has 2 carbons and it has 2 hydrogens, and it has 2 plus 2 4 oxygens, C2H2O4, right? So when you simplify it, you can simplify it by dividing the formula by 2, right? So you would get CHO2. So the formula, the empirical formula would be CHO2. Next question, calculate how many atoms of carbon are present in 0.18 grams of ethane dioic acid. Show your working. So this is a 3-mark question, but it is such a basic question. It is an IGCSE O-level question, right? They're asking us how many number of carbon atoms are present. See, so for that, we to find number of carbon atoms, right? Let me just show you by drawing a flow chart. If we want to find atoms of carbon, right, we first need to know number of molecules of the compound, which is C2H2O4. We can write this like that, right? And to find number of molecules of the compound ethane dioic acid, we need to know moles of ethane dioic acid. Moles of ethane dioic acid. And to find moles of ethane dioic acid, we are given the mass of ethane dioic acid, right? So we have been given the mass of ethane dioic acid. So we are going to use this flowchart to basically find out how many atoms of carbon are there. All right. If you did not want to use this flowchart, there are other ways as well, but all of them follow this same pattern. First of all, you can't find the number of atoms directly from the mass, because in stoichiometry, the first rule is everything goes through moles, right? Moles are what you need to find first for anything, right? If you want to calculate concentration from volume, you need moles. If you want to calculate volume of gases from mass of gas, you need moles. All right. So that is something we develop during our IGCSE or O levels years, right? So we are given we are given 0.18 grams of ethane dioic acid. To go into moles, we would have to divide it by the MR of ethane dioic acid, right? So how would we divide it? The MR is given as 90 up here, right? So we are just going to divide this by 90. So I'm just going to write this in bracket, divide by 90. So what would be the answer of 0.18 divided by 90, beta?
2 into 10 exponent minus 3.
Okay, I'll write the general stuff over here. Okay. 2 into 10 exponent minus 3. All right. Meaning 2 into 10 to the power minus 3. 2 into 10 to the power minus 3 moles. These are the moles of ethane dioic acid we have. Now we want to find the number of molecules of carbon, how many there are, right? The ethane dioic acid, right? So to go from moles to number of atoms, what do? We multiply it by the Avogadro number. Avogadro's number is written as Na or L, right? Which is 6.02 into 10 to the power 23, right? 23. So this is what we are going to do. So multiply by 6.02 into 10 to the power 23. Beta, what do you get when you multiply these two values together? I suppose you will get 12.04 into 10 to the power 23 minus 3. And so it's 12.02 into 10 to the power 20. And then you put the decimal one back. So 1.202204 into 10 to the power 21. But you guys can use a calculator to let me know.
Yes, sir, this is the answer.
All right. So 1.204 into 10 to the power 21. These are the number of molecules of C2H2O4. They've asked us how many carbons are present. So in each molecule, two carbons are present. So for this specific case, we are going to multiply every molecule by 2, because every molecule contains 2 carbon atoms. It's like saying that every pack of biscuit contains 4 biscuits. So how many biscuits are there in 8 packs? You'll just multiply 4 by 8, right? So similarly, every molecule of ethane dioic acid contains 2 carbons. So how many atoms of carbon are there in total in these many molecules? So to find that, you just multiply it by 2 molecules, and then this is going to be multiplied by 2. So when you multiply this by 2, so it will become 2.408 into 10 to the power 21, right? 2.408 into 10 to the power 21. So your final answer is 2.408 into 10 to the power 21 atoms. This should be the answer. All right, if you guys do not understand, you can let me know. The next question is, solid ethane dioic acid reacts with aqueous calcium ions to make a precipitate of calcium ethane dioate, CaC2O4. All right, CaC2O4 breaks down when heated to form calcium oxide, carbon dioxide, and carbon monoxide. Construct an equation to represent the reaction of CaC2O4 when heated. Include state symbols. All right, so they've asked us the thermal decomposition of calcium ethane dioate C2O4. All right, when it is heated, when you heat it up, before it is an ionic compound, so it must be solid, right? As it is an ionic compound right now. When you heat it up, it's producing calcium oxide, which is once again an ionic compound, so it must be solid. It produces carbon dioxide, CO2, which must be a gas, and it produces carbon monoxide, which must also be a gas. If you look at it and count the number of atoms on each side, there is one calcium. There are 2 carbons, 1 and 2 carbons, and there are 4 oxygens, 1 plus 2 3 plus 1 4, 4 oxygens. Everything is completely balanced. Identify the type of reaction that occurs when CaC2O4 is heated. What has happened due to heat? It has broken down. This kind of reaction is called thermal decomposition, right? So thermal decomposition has taken place. Thermal decomposition. breakdown of ionic compounds due to excessive heating. That is called thermal decomposition. All right. Next question. Identify another compound containing calcium ions which will also produce carbon dioxide and calcium oxide when it is heated. So they are basically asking what happens when you heat something and it produces calcium oxide and carbon dioxide. So what's the name of that compound? The name of that compound is calcium carbonate, limestone, right? You've also studied it in O levels, limestone in extraction of irons, that limestone, when it breaks down, it produces calcium oxide and carbon dioxide, right? So calcium carbonate, which is written as this calcium carbonate, and its common name is limestone, right? You do not have to write all this extra detail. What you just needed to do is write the formula. They haven't asked us to write the exact name, they've just asked us to identify a compound. So writing the formula was enough, or writing the name was enough. You don't have to do all three. Anyways, moving on to the next question. Carbon monoxide gas CO and nitrogen gas N2 are both diatomic molecules. The diagram shows the arrangement of outer electrons in molecule of CO. State one similarity and one difference in the way atoms in carbon monoxide molecule are bonded together compared to atoms in nitrogen molecule. Okay, so you need to mention what is the similarity. For that, you need to know what the nitrogen molecule looks like. So a nitrogen molecule looks like this, right? And then it has a triple covalent bond, dot cross dot cross dot, right? And because they have 5 electrons, so both nitrogens have 2 electrons that are not part of bonding. So what similarities can you see in carbon monoxide and nitrogen? First of all, you can see that both carbon monoxide and nitrogen have lone pairs, right? So that is a similarity you can mention, that both molecules of CO and N2 contain 2 lone pairs, one of each atom. Full stop. That is the first thing. Now the second thing, we should write a difference. What difference can you observe? This does not look a complete covalent bond. This is a complete covalent bond. What is this kind of bond? So in this one, if you write it as a line diagram, you can see that carbon and oxygen have a double bond. That is true. Say this is the first pair of covalent bond. This is the second pair of electrons for covalent bonding, right? Double bond. But this is not a covalent bond because both the electrons are being donated by the same atom, oxygen. How do I know these are electrons of oxygen? Because oxygen has the dots, right? So the third one is a dative bond. The third one is a dative bond, right? So we are going to say, however, the N2 molecule contain 3 covalent bonds while CO contains 2 covalent and 1 dative bond. Full stop. All right. You could even let me just see the question. Okay, so you could also tell about that both of them contain 1 sigma bond and 2 pi bonds as well, because it's triple bonds. But that is also something you could have mentioned. But we have mentioned one difference and one similarity, so it's all right. Next question. The table states the electronegativity values of carbon, nitrogen, and oxygen atoms. Use the electronegativity values and relevant details from data booklet to complete the table below. All right. So we do not have the data booklet right now. The data booklet will be provided to you in exam. How will you use it? Let's see. So, do we actually need the data booklet as well? Let's see. Number of electrons per molecule. How many electrons are there in nitrogen? So, in nitrogen, because one atom of nitrogen contains 7 electrons, and the other atom of nitrogen also contains 7 electrons. So in total, there are 14 electrons. So did you need the data booklet? Not really. Next, carbon monoxide. How many number of electrons are there? Number of electrons in carbon monoxide. Carbon has 6 electrons and oxygen has 8 electrons. So carbon monoxide also has 14 total electrons. All right. The next, types of intermolecular van der Waals forces. So in N2, what kind of intermolecular forces of attraction would be there? Because N2 contains both atoms of same electronegativity, it must contain the weaker intermolecular forces called instantaneous dipole, induced dipole, right? Sorry, induced dipole, instantaneous. Let me just write it in one line. Induced dipole, instantaneous, it's not going to come in one line. Dipole, bracket, ID, ID. These are the intermolecular forces of attraction present in a molecule of N2 nitrogen, right? But CO, because there is a large difference in the electronegativity, these guys must contain permanent dipole, right? Permanent dipole, permanent dipole. This is called PD, PD. All right. Next question. N2 is less reactive than CO, even though N2 has a lower bond energy than CO. Suggest why CO is more reactive than N2. So why would CO be more reactive than N2 even though N2 has less bond enthalpy? Matlab the bond between carbon monoxide CO has much higher bond enthalpy, means it needs a lot more energy to break. However, N2 it does not need as much energy to break. The answer is very simple, but it's not only about bond enthalpy, but it's also about bond polarity. Nitrogen is a completely non-polar bond, right? The N triple bond N is a completely non-polar bond, but the carbon triple bond oxygen is a polar bond. Why is it a polar bond? Because of difference of electronegativity. So we are going to say that CO has polarity as there is difference of electronegativity between carbon and oxygen atoms. First. On to the next question. Both carbon monoxide and nitrogen are gases at room temperature and pressure. They both behave like ideal gases under certain conditions. State the two conditions necessary for these two gases to approach ideal gas behavior. Two conditions. Well, two conditions. There are like five of them. You can write any two of them. Okay? Like for example, the first condition of behaving like ideal gas, they are all mentioned in the kinetic particle theory. And when I was teaching kinetic particle theory, I had explained to students why kinetic particle theory is still a theory and not a law. Because kinetic particle theory, for one, says that for gases to behave as ideal gases, they must have zero volume of the particles, right? The particles of gases should have zero one, meaning we know that majority of the volume of gases is empty space. Like for example, these are gases molecules. Okay. um, and these these bonds, uh, these spaces, these are empty spaces, right? But the atom itself has some volume, right? The ideal gas says that there is virtually no volume of atoms either, right? So the first condition we can say is that volume of particles should nearly be zero. Why am I writing nearly be zero? Because it can't be true that their volume is zero. That is why they've also said to approach ideal gas behavior. Matlab, get close to ideal gas behavior, not become ideal gas, because becoming ideal gas is almost impossible. All the gases in this world are called real gases. All right. And then the second one, the ideal gas is not reactive. All right. So they should have very little reactivity, very less reactivity of gas. Ideal gases are highly unreactive, reactivity of gas. All right. And then they should have a very small charge if it is present, right? They should have a very small charge if it is present, meaning if they are polar, the polarity should be minimum. Increase in polarity obviously results in more reactivity. Therefore, we say diatomic molecules behave more as ideal gases than non-diatomic molecules and other gases. And we also say that noble gases also act pretty ideally because they do not react and they do not have any charge. They're completely neutral, right? Very little charge. I'm just writing extra so that you guys remember. Very little charge on gas. ठीक है? Next, explain why N2 behaves more like an ideal gas than CO does at 20 degrees and 101. Because CO is more polar, it has a higher charge, right? So CO is more polar than nitrogen gas, and hence it has higher reactivity. All right. So it has higher reactivity and it is more polar. We could also argue and say that nitrogen N2, because it has no any sort of intermolecular forces of attraction or such, and it is made up of the two same atoms. This must have a smaller atomic radius as well. We do not know the atomic radius of nitrogen. We do not know the atomic radius of carbon and oxygen, but carbon monoxide would relatively have a larger atomic radius compared to nitrogen because of the presence of polarity as well. There will be a larger gap between the two atoms. Okay, on to the next one. Calculate the amount in mole of pure nitrogen gas which occupies 100 centimeter cube at 101 kilopascal and 20 degrees Celsius. Use relevant information from the data booklet. They have mentioned to use relevant information from the data booklet because they haven't given us the value of R in the question itself. So it must be given in the data booklet. In the previous years, you did not get data in the paper itself. Right now, when you don't scroll down because it's not on an iPad in exam, but when you go to the last page, you are going to be given a periodic table and the data of all the values and constants on the last page now, right? But before it used to be in the data booklet. So R is 8.31. This is what you needed from the data booklet. Khair, the question is very easy. It's going to be solved by PV is equals to nRT, but you need to make units straight, right? The volume that is given to us is 100 centimeter cube. However, we need the volume in meter cube. So how do we go from centimeter cube to meter cube? By multiplying it by 10 to the power minus 6, right? So it will just become 1 into 10 to the power minus 4. 1 into 10 to the power minus 4 meter cube, right? That is the first thing. Next, pressure. Pressure is given to us in 101 kilopascals, but we want it in pascals. Kilo means we have to multiply it by 10 to the power 3. So we are going to write 101 into 10 to the power 3 pascals. All right. And temperature is given to us in degrees Celsius, 20.0 degrees Celsius, but we want to convert it into Kelvin because that is how ideal gases are calculated. So we are going to add 273. If we add 273 and 20, we should get 293 Kelvin. Now that our data is straight, we can start calculating moles N, right? Calculate the amount in mole. So N is equals to RT upon PV. Okay. So N will become 8.31 multiplied by the value of T is 293 divided by Pressure is 101 into 10 to the power 3 and volume is 1 into 10 to the power minus 4. So beta, what will be the answer?
Sir, is it PV upon RT?
Oh, sorry. Yes. We have done something wrong. 1 second. Because RT goes on the other side to find N, we are going to write PV divided by RT, not RT upon PV. Okay, so we are going to write PV divided by RT. My bad. Thank you for correcting me. So it will be pressure is 101 into 10 to the power 3 multiplied by volume is 1 into 10 to the power minus 4 divided by value of R is 8.31 multiplied by value of temperature is 293. So what will be the answer, beta?
4.148, 10 power minus.
4.148. So 4.15 into 10 to the power. What will be 10 to the power?
Minus 3.
Minus 3 more. All right, good. So this will be the answer then. 4.15 into 10 to the power minus 3. All right, on to the next question. Sodium halide salts react with concentrated sulfuric acid at room temperature. Write an equation to represent the reaction of NaCl with concentrated sulfuric acid. So sodium halide salts react with concentrated sulfuric acid. So NaCl, they're saying we have to write its formula when it reacts with concentrated sulfuric acid, H2SO4. All right. So because there is only one Cl, so only one hydrogen will be substituted. It will become sodium hydrogen sulfate, NaHSO4. Have they asked us to write the state symbols? No, they haven't. So we're just going to write an HCl like this. Okay. Next, name this type of reaction. What kind of reaction has taken place? In this reaction, we say it's a displacement reaction because sodium and hydrogen have displaced each other, right? So this is a displacement reaction. On to the next question. Sodium iodide reacts with concentrated sulfuric acid at room temperature to form steamy fumes. Identify the chemical responsible for steamy fumes. Wow, good question. So, what would happen when sodium iodide is added to sulfuric acid? We know from our knowledge of group 17 chapter, right? Sodium halides, they react with sulfuric acid, and the iodide one, it reacts with sulfuric acid in such a way that it produces three types of products, and one of them produces white fumes, and those white fumes were of hydrogen iodide. All right. Next, the reaction of sodium iodide with concentrated sulfuric acid continues, forming several other products, including a dark gray solid. Identify the chemical responsible for the dark gray solid and one other product of this further reaction. Who is the dark gray solid? Beta, if you remember, they're basically pointing out that sodium iodide and sulfuric acid react in a number of ways. There were a whole bunch of products, right? The dark compound was produced because of the presence of iodine. Wow, this is open right here. Look, sulfuric acid, when it reacts with sodium iodide, it produces hydrogen iodide and sodium hydrogen sulfate. Over here, the this equation is also written over here if you guys want to remember. Okay. But once hydrogen iodide is produced, it further reacts with more sulfuric acid, right? And it can produce iodine and sulfur dioxide. It can also produce sulfur. All right. It can also produce hydrogen sulfide. Iodine is produced constantly along with water, but other products which are formed are the sulfur dioxide, sulfur, and hydrogen sulfide. Okay. So we are going to say the dark gray solid is the iodine, I2, and any other product that we can mention. So sulfur dioxide was a good answer. So sulfur dioxide is something that is also produced, SO2. All right. Next question. Explain the differences in observation at room temperature when NaI reacts with concentrated sulfuric acid compared to those of NaCl. So at room temperature, what will be the difference in reactivity? We will see that sodium iodide is producing the white fumes more rapidly compared to sodium chloride. Why? Because sodium chloride is more stable, so it is less reactive. Sodium iodide is less stable, so it is more reactive. So the observation is going to be what is produced, and those are the steamy white fumes that have been mentioned above here as well, right? Steamy white fumes are produced. So which one will produce more steamy white fumes, like faster steamy white fumes? You will say the one which is more reactive. Sodium iodide is more reactive, so we are going to say that NaCl will produce white fumes slowly, while reaction of NaI with H2SO4 will show rapid production white steamy fumes. Next question is complete the equation for reaction of bromide with excess concentrated sulfuric acid at room temperature. Once again, it is from the table. So what happens when bromide have, okay, so we are going to have to see if it is sodium bromide or hydrogen bromide. I don't actually remember from the question. But if it was sodium bromide, then it would produce HBr and NaHSO4. And if hydrogen bromide is reacting with sulfuric acid, then it is going to produce bromine, sulfur dioxide, and water. So let's have a look. So it's hydrogen bromide, okay? It's reacting with sulfuric acid, and we are going to say that it is going to produce bromine, it's going to produce water, and it's going to produce sulfur dioxide, right? And now to balance the equation, we are going to put a 2 on bromide, and we are going to have to put a 2 over here as well because this is HBr at the end of the day. So we basically have to put a 2 on both sides, on both of them, okay? And how many H2SO4 and how many H2O and SO2 will be there. So let's see. Look, if you look at the question carefully, uh, 2H plus and 2H2, meaning four hydrogens. So this should have two over here. So hydrogens are balanced. Now, how many oxygens? Two ones are two and two. Four oxygens are also balanced. So we don't need to put anything. So this can just be a one. Next, aqueous bromine reacts with methanoic acid to form hydrogen, bromide, and carbon dioxide. The table shows the oxidation numbers of bromine and carbon in species involved in this reaction. Br in Br2, C in HCO2H, Br in HBr, C in CO2. Well, all right. Identify the oxidizing agent in this reaction and explain your reasoning. So, which one is the oxidizing agent? The oxidizing agent is obviously going to be the one that has been reduced itself. So, which of these compounds has been reduced itself? We see that bromine has formed HBr. Matlab bromine has gone from 0 to -1. This is reduction, right? This is reduction. So we are going to say that bromine is the oxidizing agent. Br2 is the oxidizing agent as it increases the oxidation state of carbon before being reduced itself. Full stop. All right. Next, suggest one change you would observe ignoring temperature changes when bromine reacts with methanoic acid. All right. Suggest one change you would observe ignoring temperature changes when bromine reacts with methanoic acid. So, when bromine is going to react with methanoic acid, we are obviously going to see that bromine has become hydrogen bromide. Hydrogen bromide is colorless, but bromine is a brown solution, right? So, we are going to say that bromine has been decolorized. So, we say color of solution changes from brown to colorless. All right. On to the next question. This reaction can be followed by measuring the concentration of bromine present in the mixture at regular time intervals. The graph shows the change in concentration of bromine against time in a reaction carried out at 20 degrees Celsius. All right. Use the graph to calculate the average rate of reaction at 20 degrees Celsius during first 600 seconds. State the units. All right. So we want to calculate the average rate of reactions in the first uh, 600 seconds. So the average rate of reaction, how can be calculated? Basically, we need to find out how much initially it was, how much finally it was, right? And then we are going to have to find out how much it reacted, right? So from 100, we have gone down to 0 to 20, tak, meaning this is 4, 8, 12, right? And it's in 10 to the power 5. So 100 into 10 to the power 5 minus 12 into 10 to the power 5. What do we get?
8850 zeros.
8, 8, 5 zeros. Acha, nahi, 5 zeros like this. 1, 2, 3, 4, 5, comma, comma. Right? We are going to have to divide it by the total time because these are the total number of molecules that have reacted, right? So 8,800,000 divided by 600. What do we get, beta?
14666.6.
14666.67 mole per dm cube per second, right? Because top was concentration divided by time, right? So mole per dm cube per seconds. So the answer is 14666.67 mole per dm cube per second. The experiment is repeated at a temperature of 40 degrees Celsius. This relatively small increase in temperature produces a large increase in rate of reaction. Sketch a graph on the same axis to show the expected result when repeating experiment at 40 degrees. The rate of reaction, अच्छा सही तो बाकी part start होगा तो we just have to sketch the graph. So when the rate of reaction increases, gradient of graph increases basically. So you want to make a line with a greater slope. So a line with the greater slope, but it should also produce the same amount of product. That is basically it, right? I had drawn quite, this is quite fine. I mean, you are going to have to draw a more vivid line. On an iPad screen, drawing lines straight is very difficult for me. Uh, on the page, you will find it much more smoother to draw, right? So basically, you had to draw the same reaction, but because it is happening at a faster rate, so it will produce all the products and it will end the reaction much faster. Okay. Next question. The rate of reaction increases when frequency of successful collisions between reactant particles increase. Explain why an increase in temperature produces this effects. So they've basically explained to us that increase in temperature increases successful collision, but they've asked us why. So you have to explain every time when temperatures increase, what increases first? The kinetic energy, right? So you're always going to explain increase in temperature increases the average reactant particles. Stop. Hence, particles now collide with each with great force and frequently. Full stop. Next question. Complete the dot and cross diagram showing outer electrons only to show the bonding in methanoic acid HCO2H. Okay, if you ever find it difficult to do dot and cross diagrams, always do line diagrams first. So methanoic acid is HCOOH, right? And HCOOH looks like this. And everywhere where there is a single bond, it means one pair of electron. Everywhere where there is a single bond, it means one pair of electron. So meaning this should electron, this should have one pair of electron, and this should have one pair of electron, right? And then this is a double bond, so this should have two pairs of electrons. So just draw two pairs. Right? Okay. So we are just going to draw some more crosses for oxygens. So automatically now we are going to consider that oxygen is the one that has all the crosses. Okay. So this should be complete. Next question. Naphtha is a mixture of which contains only hydrocarbon molecules. Okay, what is meant by hydrocarbon? A very basic question. Compounds containing compounds containing carbon and hydrogen only. That is what naphtha is. Next, name the raw material that is used to produce a sample of naphtha. Where is naphtha produced from? We know it is produced from petroleum, which is also called crude oil. All right. Next question. Compound V is found in naphtha. It has a molecular formula of C10H22. When V is heated at a high pressure, in the absence of air, an equal number of moles of ethene, propene, and W are made. W is a compound made of straight chain saturated molecules. Name the process that describes this reaction. बेटा लार्ज मॉलिक्यूल था, उसको हाई प्रेशर पे आपने हीट किया तो अल्कीन बन गया. What does that represent? Cracking, right? Reduce the structure of W, draw its structure below. Okay, well, let's see. Compound V is heated at high pressure. In the absence of air, an equal number of moles of ethene, propene, and W are made. W is a compound made of straight chain saturated molecules. So we don't know W yet, but we need to understand what has happened. So C10 H22 has just broken down into ethene, which is C2H4, and propene, which is C3H6, and it should also produce equal proportions, meaning all of them are in the ratio 1 is to 1 is to 1. So C2H4, C3H6, so W should have how many carbons? Out of 10, 5 have been used, so C5, and out of 10, out of 22, 10 hydrogens have been used, so 12 hydrogens are left, C5H12. This should be um, W. So we want to draw the structure of W. Structure means we can draw it like this: CH3, CH2, 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 and CH3. All right. So CH3, CH2, 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 CH3. This is what all the molecules will be. The structure. All right. You could also do this CH3 because in the middle CH2 is thrice. You could do CH3, CH2 whole thrice, and then CH3. These are two ways of doing it. On to the next question. Propene is separated from the mixture and heated in air in the presence of catalyst. Propene is oxidized to X, which contains two functional groups. Okay, so propene is heated in presence of a catalyst. Propene is oxidized, and it is oxidized to X, which contains two functional groups, and X contains two functional groups. Effervescence is seen when Na2CO3 is added to X. When sodium carbonate is added to X, effervescence is seen. Identify the functional group present in X which is responsible for this observation. So sodium carbonate, which organic compound does sodium carbonate react with? If you remember, sodium carbonate ka chemical reaction is only discussed in the reactions of carboxylic acids because they are acids, and sodium carbonate is a metal carbonate. They react with acids, right? So the only group that reacts over here is the carboxylic group, the COOH group. All right. Next, identify a reagent which could be used to show that X contains carbon-carbon double bond. Include relevant observations. Amazing. So, how can you test for carbon-carbon double bond? Meaning test for unsaturated carbons. So, you do what? You add bromine water. Bromine water is the test for unsaturated carbons, right? Carbon-carbon double bonds. If compound contains unsaturated carbons, color of solution will change from brown to colorless, right? You have to add the detail. Next question. X reacts with another reagent to form Y. Molecule of Y reacts together to form addition polymer Z. Mashallah. The diagram shows the repeat unit of polymer Z. Repeat unit of polymer Z looks like this. Okay. So ये तो ऊपर की कहानी है. It is of no use. Draw the structural formula of the monomer. Wow. So we have to draw the structural formula of the monomer. So this is a carbon, this is a carbon in the monomer because this is a single repeat unit. This is one of the easiest questions that would have ever asked. बस यहाँ पे double bond बनाना है आपको और skeletal structure नहीं बनाना है, structural formula बनाना है. So you are going to draw a carbon-carbon double bond, all right, and then you're going to draw the carbon, double bond oxygen, single bond oxygen, and Na, all right, and hydrogen, hydrogen, and hydrogen, right? This is the compound, okay. Um, Next question. Polymer Z is useful because it absorbs large amounts of water. However, there are problems associated with disposal of products containing polymer Z because it is an addition polymer, of course. Combustion is not an appropriate method to dispose pure Z because process releases harmful gases. Some of these gases contribute to enhanced greenhouse effect. Identify a gas released during combustion of Z which contributes to enhanced greenhouse effect. So greenhouse effect is produced by greenhouse gases, and when you combust something, the greenhouse gas that is produced is carbon dioxide. Carbon dioxide, CO2. All right. CO2 is the greenhouse gas that is produced. Next question. Identify another gas which could produce during combustion of pure Z. Describe a consequence other than enhanced greenhouse effect of its release into the atmosphere. Another gas which could be produced during combustion of pure Z. Where is pure Z? This is addition polymer pure Z, right? So they're saying other than enhanced greenhouse effect and its release into the atmosphere. Okay, so this is pure Z, right? It contains no chlorine. Otherwise, we could say that it produces combustion produces hydrogen chloride. It contains no sulfur. We could say otherwise it contains produces sulfur dioxide. It contains no nitrogen. Otherwise, we could say it produces nitrogen monoxide, nitrogen dioxide. Right? We can't answer any of these. So the only answer that this question could have is the incomplete combustion of this compound would produce carbon monoxide, right? Because carbon dioxide beta jahan banta hai na, wherever carbon dioxide is produced, there is 100% chance. मतलब कोई मतलब दूसरी राय है ही नहीं. Whenever you burn carbon dioxide, there is going to be a chance that carbon monoxide is also produced if you burn something for long term in a closed environment, right? So carbon monoxide is something that could produce carbon monoxide, CO. What does it do? What is its consequences? It is toxic. Why do we call it toxic? Because it decreases the oxygen carrying capacity of hemoglobin. Full stop. If some students wrote it binds irreversibly to hemoglobin, that is also a consequence. Correct, 100%. सही है. इसको ही दूसरे तरीके से कैसे लिखा जा सकता है? It binds hemoglobin. It binds uh, irreversibly to hemoglobin. सही है? तो ये भी लिखा जा सकता था. खैर, तो this is how you answer the question. On to the next question now, beta. Question 6. सही है. Catalyst to form an alcohol with molecular formula C3H8O. All right, so this is H2O से रिएक्शन हो रहा है एल्कीन का. क्या कहते थे इसको? एडिशन रिएक्शन. बट पूरा नाम बताओ, क्योंकि एडिशन रिएक्शन तो हम ओ लेवल्स और आईजीसीएसई में भी कहते थे. द फुल नेम वाज इलेक्ट्रोफिलिक एडिशन रिएक्शन, राइट? दिस वाज इलेक्ट्रोफिलिक एडिशन reaction. They're probably going to ask us the mechanism soon, I think. Name the catalyst used and state the conditions needed for this reaction. The catalyst used was phosphoric acid, if you guys remember, H3PO4, phosphoric acid. And what were the conditions required for this reaction? Beta, you required 300 degrees Celsius of temperature and 60 to 70 atmosphere pressure. Two conditions you require for addition of steam to alkane. ठीक है? Complete the table to show the number of sigma bonds and pi bonds present between C3H6 and C3H8O. So C3H6 contains carbon, double bond carbon, single bond carbon, and hydrogen, hydrogen, hydrogen. Only one hydrogen here and two hydrogens here, right? So if I start counting, so sigma, 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 sigma. This is also sigma and this is also sigma, right? So how many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. It looks like there are 8 sigma bonds, all right? Eight sigma bonds. And how many pi bonds are there in C3H6? Just one, because there's only one double bond, right? Only one pi bond, right? So we're going to write it as one pi bond. And what about C3H8O? So what is it? It is an alcohol, right? Yeah, because they were talking alcohol that is produced from propene. Yeah, but the alcohol just confirming. So C3H8O is going to be carbon, 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 oxygen, hydrogen, 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 and hydrogen. As you can see, all are sigma bonds. Why are all sigma bonds? Because every single one of them is a single bond. The first bond between two atoms is always a single sigma bond. तो जहां जहां पहला बॉन्ड है, पहले बॉन्ड को सिग्मा काउंट करेंगे. Then second and third bond is always pi. So all of them have single bonds. So how many are there? 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sigma bonds. And because there are no carbon double bonds or carbon triple bonds, so 0 pi bonds. Okay. Next question. The reaction of propene C3H6 with H2 occurs in a two-step mechanism. In step 1, C3H6 reacts with catalyst H positive. Okay. To form carbocation. So yeah, asking us for stable and less stable carbocation. But first of all, just in an empty space, we need to understand where the carbocation will form. So basically, let's draw the structure of propene over here. Carbon, carbon, single bond carbon. These are all hydrogens, right? This is also a hydrogen, and there are hydrogens right here. Okay, this is right now complete C3H6, right? When electrophilic addition takes place, this bond gets broken, the double bond, right? And only one of the bonds is remaining. So now at this point, from the very beginning, if you see, partial positive, the electrophile, and the OH is the partial negative. So the electrophile attacks the electron dense region, which is the carbon double bond, which makes this bond break, right? If this bond breaks, then this hydrogen either joins with this carbon, so this becomes a carbocation, or the reverse happens, that this hydrogen joins with this carbon. So this carbon becomes the carbocation. Any one of the two carbons becomes the carbocation, right? So if this is the carbocation, then what do we call it? And if this is the carbocation, then what do we call it, right? So first of all, we can draw the two carbocations, and which one is more stable, because we have to draw it in the right one. More stable carbocation. Better we say that according to not Vesper theory. I keep confusing it. Not Vesper. Markovnikov's rule, right? According to Markovnikov's rule, the more stable carbocation is the secondary compared to the primary, and tertiary is the most stable. Right now, we only have a choice between secondary and primary. Like for example, if we have this carbocation, right? This is the first carbocation, and then we could just duplicate it to show you the second carbocation as well. Okay, this is the second carbocation. You can clearly see that this is the secondary carbocation because the carbocation is joined to two carbons, and this is the primary carbocation because the carbocation is joined to only one carbon and two hydrogens. All right, so primary carbocation is less stable, secondary carbocation is more stable. So let's take it in the more stable column, more stable carbocation, right? And this is the less stable carbocation. Let's take it in the this column. Okay. Um, and the explanation why is secondary carbocation more stable and primary carbocation less stable, because of the presence of the inductive effect, right? This carbocation is experiencing inductive effect from both sides. Electron clouds are covering it from both sides, right? But this carbocation is only experiencing inductive effect from one side, right? So we are going to say that secondary carbocation is more stable than primary carbocation due to its increased positive inductive effect. Why is it called positive inductive effect? Because the carbocation has a positive charge. If this carbocation had a negative charge, then this would be called negative inductive effect. But carbocation नेगेटिव कैसे हो सकता है, वो कार्बो एनायन होता. बट जनरली स्पीकिंग कभी अगर नेगेटिव चार्ज हो तो पॉजिटिव इंडक्टिव इफेक्ट नहीं लिख के आना, वहां पे फिर नेगेटिव इंडक्टिव इफेक्ट लिखना. कहने का ये मकसद है, ठीक है? तो इंडक्टिव पॉजिटिव इंक्रीज पॉजिटिव इंडक्टिव इफेक्ट ड्यू टू two carbon chains joined to it. Full stop. All right. On to the next question. Name the major organic product formed from reaction of propene. So, which is the major one? The one which is more stable. So, the one which is more stable is going to finally get an OH on this one, meaning 2-propanol, right? 2-propanol will be the answer, right? Or we could also say, or propane 2-ol. This is also it is written. Next, 2-bromopropane reacts to form propene, hydrogen bromide, and water under certain conditions. Name this type of reaction. So when you have one compound breaking into many different compounds. This reaction is called elimination reaction, right? This reaction is called elimination reaction. We studied this reaction in where did we study this reaction? We studied this reaction in halogenoalkanes, halogenoalkanes, right? In halogenoalkanes, we studied that if we react a halogenoalkane, let's suppose 2 bromopropane, है ना? 2 bromopropane is CH3H7, C3H7, Br, right? It can react with sodium hydroxide in its aqueous condition, all right? Or it could also react with sodium hydroxide in its ethanolic condition, right? Ethanolic sodium hydroxide. Beta, this reaction, the first one, this reaction is called a nucleophilic substitution reaction, and this reaction is called the elimination reaction, right? The product of this are very simple: C3H7OH plus NaBr, right? The product of this is elimination to C3H6 plus HBr plus NaOH, and then the NaOH and HBr further react to form sodium bromide and H2O, right? So over here, what do we need? We need reagent sodium hydroxide, NaOH. And what do we need the uh, condition? We need to have ethanolic solution. या यूं लिख लो, reaction should take place in an ethanolic solution. Reaction should take place in ethanolic solution. Full stop. All right. So with that, this paper of 2021 has been completed. If you guys have any questions, you can let me know.